Hello and welcome to the channel. Today we're checking out an awesome video from PBS Space-Time channel. You should go check them out. The video is called Could the Universe Be Inside a Black Hole? Awesome channel, awesome content. This video brings about a concept that is very interesting. I know we're all fascinated with black holes. Could that be the entrance or the creation of another universe? Does that make sense? Maybe, maybe not. We're going to find out with this video. If you're interested in fascinating videos like this, milestone we're trying to get to is 100 subs. Make sure you like, comment, and subscribe. And if you have any videos you want us to go check out, make sure you leave it in the comment. Let me know. All right, let's get right into the video. Thanks for watching.
What is inside a black hole? Inevitable crushing doom? Gateways to other universes? Weird multidimensional life?
I think probably crushing doom for sure, for certain. You know what I mean? For certain, you're not coming on the other side of that black hole as you existed in this side of existence.
Libraries. If you've ever wanted to know, then you might be in luck. Some physicists have argued that you are inside a black hole right now.
Could that be the Big Bang, the creation of a black hole?
Einstein's ridiculously successful general theory of relativity has never failed. But we know it must fail at the centers of black holes and at the Big Bang.
Why does that have to happen? Couldn't just there be new variables that get introduced in that scenario? To even understand black holes, I think black holes were predicted because of the formula and then later on verified. So how did that break his theory? Don't think it does.
Both of these involve matter being packed to infinite densities. They are singularities where the mathematics of GR breaks down. Well,
Singularity, that's the idea behind the black hole, right? Also, that's the idea behind the Big Bang. It was a singularity, then inflation, cosmic inflation happened. Correct?
It turns out that black holes and the Big Bang have more in common than vexing Einstein.
There we go.
They have mathematical similarities to each other that have led some physicists to believe that the Big Bang is in fact the singularity of an absurdly gigantic black hole. Let's figure out how crazy this proposition really is.
How massive of a black hole do you need to be to contain the whole universe? Could it be the end of the Hawking radiation and where the black hole evaporates to a point where it explodes? Is that the black hole? I mean, the Big Bang?
First up, black holes. Collapse any chunk of matter far enough and it gets stuck in its own gravity. In general relativity, that looks like a point of infinite density surrounded by an event horizon. We can think
So he explained it in general relativity.
of the event horizon as the surface where the flow of space is like a river moving at the speed of light. Nothing can swim against that flow. From the outside, the black hole looks like an orb of blackness at a particular location in space due to the fact that nothing, not even light, can travel back out from below the event horizon. The universe also has a singularity and an event horizon. The singularity is the Big Bang, which we think of as a point in time at the beginning of the universe when all matter was compressed to infinite density and all points in space overlapped.
So that parallel is very, very significant, right?
From the Big Bang, space expanded and it's still expanding. That expansion gives us our event horizon. If space is expanding evenly everywhere, then there are distant regions of the universe that are being propelled away from us faster than the speed of light. That means there's a surface at a particular distance that represents the limit of our observations, in that we can never know about any event that happens beyond that surface. This is the cosmological event horizon. Now, it's somewhat more complicated. For example, we're still receiving light from objects that are now beyond that horizon because it was emitted by those objects before they crossed the horizon.
But they'll never reach us because that space in between keeps expanding. And there's so much space that it becomes faster than the speed of light.
Also, the accelerating expansion of the universe means that the cosmological event horizon is closer to us than the spot where the recession equals the speed of light. But the effects are the same. no events that happen now beyond that horizon can ever be seen. Complications aside, there are striking similarities between the black hole and the universe. The obvious difference is that the black hole singularity seems to us to be a point of infinite density in space, while the Big Bang singularity is a time of infinite density that included all space.
Seems like a big difference right there, right? Where including all space, everything, all of existence versus, finite.
Actually, that difference isn't as different as it sounds.
He's about to prove me wrong. Okay.
Both the Big Bang and the black hole singularities do occupy all space.
Really? A black hole occupies all space?
The difference is that the Big Bang singularity exists in the past for all of space.
Oh, I get what he's trying to say.
While the black hole singularity exists in the future for all of the black hole space.
Technicalities.
Okay, now that last part probably needs a little more explanation. We've talked about an idea called geodesic incompleteness in a couple of episodes. In our recent one on the centre of the universe, and also when we asked what happened before the Big Bang. We're going to need that idea again, so here's a refresher. In general relativity, objects that are not being acted on by a force follow something called a geodesic. These are just the straightest paths that can be taken through a curved space-time. In a sense, geodesics form the grid that defines the fabric of space-time. It's possible to define a geodesic at some point in space and time, say the arc of a ball thrown through the air. Then you can trace that geodesic forwards and backwards. That trace will define the path of the thrown ball, but you can also extrapolate beyond the ball's trajectory. That would be the path that the ball would follow if it could pass through the planet, or the path through the ground that could have brought the ball to its current position. And you can keep tracing the geodesic into the infinite future or all the way back to the Big Bang.
All the way to the Big Bang. Picture that.
It's defined for all past and future times independently of the ball. Geodesics generally don't just end, except at singularities. In fact, in general relativity, singularities are defined as the endpoints of geodesics. All geodesics in the universe come together and terminate at the Big Bang. We call the Big Bang a past space-like singularity.
So this is very interesting. This is like deterministic type of viewpoint mathematically, where everything started at a certain point, and at the beginning of the universe, the creation of the universe, and it could literally be traced. If you have the ability to compute every mathematical variable, you'd be able to completely know the future and the past of every object with perfect information and the ability to compute all these variables. That's very interesting. You ever think that could be ever achieved? The problem is you need perfect information, which is impossible to have, right? But can you make predictions based on the current state of things into the past? We already do that to an extent, but maybe with supercomputing, AI, data mining, this could be taken to a whole nother level.
Because it occupies all space in the past. A black hole contains a future space-like singularity, which means that all geodesics within a black hole space-time end at the singularity in the future. No, that doesn't mean that you are doomed to be crushed by a black hole. I mean, you might, but you might not. The black hole singularity is the all-encompassing future for the space-time that lives beneath the event horizon, in the same way that the Big Bang is the encompassing past for the outside universe. So the black hole and the Big Bang singularities are starting to look more alike, with the difference being their residence in the future versus the past, and the fact that black holes are embedded within a greater universe, while the Big Bang is the entire universe. How do we make a black hole look more like a universe? We'll need to make the black hole interior mathematically indistinguishable from a universe for somebody.
But here's the thing, right? With black holes, the more matter they consume, the larger they become. Right? So that means there's an input, output, variance, and correlation, right? So to get another universe, another baby universe within a black hole that exists here that consumed just a portion of the universe we live in, doesn't mean on the other side the universe doesn't have as much materials to work with. Is it literally a baby universe? Well, when I mean baby universe, maybe because like in Einstein's theory, right, mass is energy, energy is mass. It could be converted. Black holes consume mass, and mass is energy. The Big Bang was pure energy at the beginning, correct? So does that mean those baby universes have a whole lot less energy, mass to work with? Interesting concept, but does it break down at that point where to say that maybe the Big Bang is just maybe a more massive form of a black hole that we see in our existence? But how did that happen? How does that happen? How does a black hole form that contains this much mass and energy as the one that we exist in?
Body inside that black hole. The first step is to send that singularity to the past. A time-reversed black hole is easy enough. It's a white hole. And it's a valid solution to the Einstein equations.
White holes.
Naturally, we've discussed these before. The past space-like singularity of the white hole is surrounded by an event horizon that is the opposite to the black hole event horizon. It can only be crossed from the inside to the outside. Space flows at the speed of light across the event horizon from within. That's starting to look like our universe.
So the Big Bang was a white hole? Black hole is just the other side?
A past space-like singularity and an event horizon that can't be crossed from the outside. But there still is an outside in which the white hole just appears as a bright but localized point in space. The outside region doesn't share the same singularity origin as the white hole. On the other hand, anyone inside the white hole wouldn't know that. So could they be fooled into thinking that they are in a regular universe? At first glance, despite the similarities, the interior of the white hole looks nothing like our universe. Now, the white hole was discovered by messing around with the coordinates of the OG black hole solution by Karl Schwarzschild. The same trick gave us wormholes and mirror universes.
Have white holes been discovered in real life, though? At this point, it's all theory, right? That white holes exist? Let me know in the comments.
And we mapped those weird spaces in a previous episode. The interior of this type of white hole looks nothing like our universe. For one thing, it's made of pure space-time, no matter included, and it's highly inhomogeneous. The curvature changes dramatically as you approach the singularity. But our universe appears...
But the Big Bang, because of the CMB, looked very homogeneous.
...be highly homogeneous. Matter and energy are very evenly spread out, and it was even more evenly spread out in the early universe.
Flat curvature.
And the space-time curvature is nearly flat, so no crazy tidal forces like in a white or black hole. The space-time of our universe is well described by the Friedmann-Lemaitre-Robertson-Walker metric, which we also talked about in the Center of the Universe episode. But there's actually a way to fit an FLRW metric inside a black or white hole, so those inside couldn't tell the difference. The first realistic mathematical description of a black hole formation was discovered in 1939 by Robert Oppenheimer of atomic bomb fame, along with his student...
Oh, this guy. Even more famous recently for the little movie.
Hartland Snyder. They approximated the collapse of a star by modelling it as a spherical cloud of matter with a perfectly homogeneous density and zero pressure. The thing collapses under its own gravity and an event horizon forms around it. But within the collapsing cloud, the matter remains homogeneous and the spacetime is flat until it becomes a singularity. Now, real stars don't look like this. They get denser towards the centre and have plenty of pressure. But the Oppenheimer-Snyder solution gave our first insights into black hole formation. And it also showed another weird property. This assumption of homogeneity and zero pressure was the same assumption that Alexander Friedmann made when he first solved the Einstein equations for the whole universe. and it's the assumption behind the FLRW metric. In fact, you can describe the space-time of a collapsing star by patching one of these FLRW metrics inside a Schwarzschild metric for a black hole. And that's true even after the black hole's event horizon forms. So you can have what looks like a black hole from the outside, but looks like comfortably flat space inside the still collapsing star. If it works for the black hole, then it should work for the white hole. Just flip the time axis and you have a white hole containing a bubble of expanding space that looks much like our universe. If such a white hole was big enough, it could look exactly like our universe. This was the
But how would that happen?
basic proposal by Indian physicist Raj Patria in his black hole cosmology hypothesis back in 1972. As far as I've been able to tell, no one has convincingly shown that this can't be true. There's also the idea that universes are born as white holes produced after the collapse of a black hole. That's cosmological
I'm curious, does anybody have any theories on how, after the collapse of a universe, that could happen? The only way I could see it is if just brings all of matter in a universe back together to create this giant white hole.
Natural Selection by Lee Smolin. And yeah, we did an episode. In that case, black holes don't form singularities but rather bounce back outward to create new spacetimes from the resulting white hole, which itself creates new black holes, etc. Okay, so we need...
Imagine how trippy that would be. That existence is infinite in that way, where black holes create white holes, and this loop just keeps happening from universe to universe within a universe within a universe within a universe for infinity and beyond. How does that even happen? Where does that even start? It is incomprehensible, right? If you think about, our human brain is always thinking in beginning and ending, starting, creation. And there might never be an answer. There might be no beginning. How are these laws of the universe created? How does that happen? How does something come out of nothing? How does something exist out of nothing to a point where it has all these rules? There's like rules to the universe, rules to physics. And there are certain places where it seems like those rules are broken, like in a black hole. But in general, there's freaking rules to the universe. And to us at this point, I don't think like the universal constants, it's very particular. It's particular numbers that exist. It's like a particular setting. If you go into a software and you go into the settings and you go and choose preferences, that exists for the universe. And it could be all random chance that, we hit all these different settings that happen to give rise to the opportunity for life to exist. But maybe we're one iterations of like infinite amount of universes that happen already, that are still happening, that got it right. And we were just lucky like that, like hitting the lottery.
Need one last ingredient to be able to answer maybe to the question that we started with. Are we in a black hole? In 1999, Stephen Hawking showed that if a black hole is leaking its mass via Hawking radiation in perfect equilibrium with the radiation that it absorbs, for example from the cosmic microwave background, then the line between the white hole and the black hole becomes unclear. They could be the same object. If you lump all of this together, a very specific construction for white holes to make them look like our universe from within.
But okay. The process with Stephen Hawking's Hawking radiations, where new matter is created on the horizon, it's a very slow process, right? Super slow, super tiny. But shouldn't a white hole be as fast as a black hole is in absorbing matter? White holes should be releasing it as fast as... Just a question. I'm not basing this on anything, but that was my assumption, that white holes are releasing matter at a very high rate and speed, just as fast as, a black hole could consume matter and energy.
And Hawking's argument that equates white holes with black holes, then there's a roundabout way to argue that we might not be in a black hole. So is the universe a black hole or a white hole? Well, probably not, but not absolutely not. There's no good reason to believe that...
Probably not, but not absolutely not.
This is the case, and so we shouldn't believe that the universe is a black hole. We need some deeper explanatory value.
Okay, so that's the conclusion. We're not in a black hole. Well, not most likely. Just like that. Say it exactly like that.
Value to this hypothesis to really take it seriously. Cosmological natural selection might be a path to that, but we also need some evidence for that in order to proceed. However, if we are in a black hole, then there is a huge upside. We now know what the interior of a black hole looks like. It looks...
That's after you pass the time horizon. But then at what point of a black hole do we know what it looks like? Just because, say we are in a black hole, could we really be on the horizon where between the space between the horizon and the singularity? Could we be there? That's not likely because physics would be different. Are we in the singularity? Again, in the singularity, that's the compression of all the matter that's ever entered into a black hole, all infinitely dense in an infinitely small point. We couldn't be there either. It has to be beyond that, right? Maybe someone could explain that to me in the comments. Would love to know.
Looks like this. And there are indeed libraries in this black hole. Perhaps one day one of the books in these libraries will also answer the next question. If we're within the event horizon of a black/white hole, what's on the outside? Maybe a universe inhabited by people asking the same question with the same answer.
Endless loop.
That they are in a black hole, and so on ad infinitum in a series of black holes forming an infinitely nested space-time.
It's like holding up a mirror against another mirror, and then you see the reflection, and within the reflection, within a reflection, within the mirror of the reflection. But it's very fascinating stuff. There's a lot of parallels we see. You could obviously see between what potentially happened at the Big Bang period of the universe and what black holes look like and act like right now. Very fascinating to think about it. When he says what it looks like to be inside a black hole, he must mean something beyond a place where everything turns into spaghetti and everything turns into a singularity, right? Beyond that, on another side of a white hole where it's spitting things out. But just, in general, this is just so crazy to think about all the potential of how we got here, right? And if you enjoy these type of videos, make sure you like and subscribe. Help me get to 100 subscribers. We're on the march. So see you in the next one. Thanks for watching. Mecca out.